And first of all, I would like to acknowledge my thanks to the organizers for bringing me in this very unique land in this planet, Victoria. And it was also my dream project to visit Canada once. A very long distance. It was about 72 hours journey for me from India, and big layover also. And also, I just want to acknowledge my thanks to my university and Indian Council of Social Science Research for providing me the fund to visit this place. Anyway, so my talk is already, as he told, that it is natural disasters in the Garhwal Himalaya, drivers, implications and mitigation measures. So these will be the key points of my presentation. Like I will talk about some methodology part also, frequency of and ranking and month-wise frequency of disaster incidents, loss of property and life, disaster hotspot. Some case study I will talk about Bandal Valley, and also I will talk about major drivers of geohydrological disasters and risk reduction and mitigation measures. These will be some key points for my presentation. So if you see this region is called the Garhwal Himalaya, is also called the Central Himalaya, one of the very important segments of the Himalayan region. It is highly prone to the natural hazards, particularly the geohydrological hazards. I will show you how the region is being affected, and particularly under the climate change one. So there are many geohydrological disasters like landslides, flash floods, cloudburst, debris flows, rock falls, extreme weather and land subsidence are prominent among them. There are some cases where the land is being subsidence in the high Himalaya. The township also going sinking down. Like this, so many examples are there. And also cloudburst and glacial bursts are very common. Sometimes there are lots of glacial bursts also, and they are all damaging the downstream settlements and economic avenues. So these are some very important geohydrological disasters, and they are triggered by either the cloudburst or the glacial burst, and they are very common phenomenon in this region. So this is the methodological part of my study, that most of the study is empirical because we collected data from the field. And then we have case studies, we have household level survey, we have interviews of affected people, we have also participatory observation field survey, and we also collected secondary data from Department of Disaster Management, print media, electronic media, Sentinel, One SAR and Google Earth before and after. And then we have data analysis like descriptive stats, we use frequency, rank methods, digital cartography and mapping, GIS for dam and GPS, and construction of profile. So these are some data that they are related from 2021 to 2023. There were about 183 major disaster events. So if you look into this table, that you see that in 2021 there were total 34 incidences. In 2022 there were 98. In 2023 51. In total 183 within a span of 2 years. And then we have also ranked these the disasters like you know that the highest rank of the disasters is landslides, very common, then flash floods, then cloudburst, then debris flow, then rockfall, extreme weathers, and there are, as I told you, some incidences of land submergence all over the Himalayas, and particularly the central Himalayan region. So when we look into the month-wise frequency of disaster incidents in that region from 21 to 23, we can see that because 3 months, July, August and September, they are the months for monsoon rain, very high downpour there. Sometimes the rain is more than 100 millimeter in within 24 hours. So if rain is 100 millimeter within 24 hours means it is cloud burst. So that if you see also this month-wise, so highest rainfall occurred in July, it was 51.4%, and then in August 29.9%. In September is a receding monsoon, so the rainfall intensity is comparatively less, and also the year-wise also 21, 22, 23. You can see these are incidences, as I told you, total 183. So this study is basically, as I already informed you, is empirical based on the field survey.